Good morning, everyone. My name's Declan Wray. I work at Verder Pumps. Thank you for taking the time to join us this morning. It's greatly appreciated, and I hope it will be useful for yourself and your colleagues. So I'd like to make a start with our presentation. So one of the sort of questions I'd like to start with, the question is, why do we have hygienic pumps? The reason why we have hygienic pumps is for our food and beverage industry. It's important that the stuff that we buy in the supermarkets and the shops is to the correct standard. Is there anybody else who would like to answer the question of why do we have hygienic pumps?
Nobody's answering at the moment, Declan.
No, that's no problem. I'll make a start with the presentation. That's fine.
Okay, just Declan, I'm just answering a question from Felix here. And Felix, yes, there will be a link to the YouTube channel. Danielle will send that to you when she sends out the feedback, etc. So don't worry about that. Thank you, Declan.
No problem. Thank you, Ruth. So this presentation is about pumping solutions, the hygienic, cleanability and product handling. So the question, what makes a pump hygienic? There's a few things that all tie together to make the pump hygienic. It starts with the materials, so the casing and elastomer, the casing and the wear parts, the impeller, anything that touches the actual medium will be of stainless steel. There's different elastomers for different temperatures, so that would depend on what product you're pumping and at what temperature. There's the connections, so hygienic connections such as DIN 11851, different connections, and that can be down to the application and also what is on site in terms of your pipe work, but also what we recommend as manufacturers, and also again to the hygienic standards. The flow path of the pump. So it's important that there's no dead spots where bacteria can build up. It's important that you have a nice smooth finish inside the casing and the impeller for all the parts that come into contact with the pumped medium. The external protection. So is the pump covered? Is it up to the environment that it's placed in? Make sure there's no ingress can get in, dirt, dust, things like that, and work its way into the pumped product. And last but not least, certainly is compliance. Is the pump to the certain compliance for the environment and for the industry that it's serving, i.e. the food and beverage industry. Next slide. Sorry about that. The risks. What's the difference between choosing an industrial pump and a hygienic pump? Hygienic pumps are usually stainless steel, but just because something's shiny doesn't always mean that it's clean. So you can have a stainless steel pump, that doesn't necessarily mean that it's a hygienic pump, and that comes down to the design of the unit. And likewise, an industrial pump, you can also use them on certain applications in food and beverage industry where the standards aren't necessarily needed. So the risks of using an industrial pump for a hygienic application, it can become an inherent bacteria trap. If there's right angles and dead spots where the fluid's not reaching, this is where there can be a bacteria build-up. And obviously them bacteria's the microscopic, you can't see them under the human eye, but they can work their way into your beer or something you've distilled, or the food or whatever it might be that you're pumping, and that can be very dangerous. There's longevity against the cleaning chemicals. So hygienic pumps, as a rule, are usually capable of CIP, which means clean in place. Industrial pumps might not have the longevity to stand up to the temperatures or the chemicals that is used in the CIP processes. Handling of difficult fluids. So there's applications that require different pumps for different applications. If something's viscous and nasty like syrups and stuff, you may want to use a rotary load pump as opposed to a centrifugal pump. So it's all about specifying the correct pump for the correct application and taking into account the difficulties of handling the different fluids. Also living with it day to day, the cleaning, as mentioned, against the CIP with the cleaning. Can the industrial pump stand up to the rigours of the CIP that's needed for the hygienic applications? Also the environment that it's based in. You know, there's different, is the motor to correct IP rating for the wash down and things like that. So as important it is for the pumped medium, it's also important to specify the correct materials for the environment that the pump's going to be based in. Materials in the stainless steel hygienic pumps is, as I mentioned, just because it's shiny doesn't mean that it's clean. So you have electro-polished. This is what we do at Verder to ensure that our hygienic pumps meet the correct standards. This is an example of mechanical polishing. As you can see, there's some ridges in there to the naked eye. This is obviously under a microscope, but these will be bacteria traps where bugs and bacteria can live. And the same with the glass beading. If you look as an example, there's these sort of tight right angles where, you know, bacteria could live and the CIP might not flush it out properly. That's just sort of 3 examples of, again, just because it's shiny doesn't mean that it's clean. It's important to have a cleanable design. So minimize right angles, have a flow path for your CIP product. Again, there's an O-ring there to stop the right angles, but as you can see, there's still a path there for the CIP product, so it cleans the O-ring, so your O-ring's not acting as a bacteria trap. Again, O-rings there, O-rings there. This is your flow path for your CIP, and again, it's over here on the right-hand side in a more detailed 3D version. Shear wall of the pump casing. So as you can see, sort of 3D model. This is your casing. The red spots sort of are where potentially the pump shearing, so there might potentially be dead spots there. So it's important that obviously the less red, the better. You can see the more blue and green colours means that the fluid's reaching these points and it's not acting as a bacteria trap. Sorry, excuse me about that. I do apologise. Again, the velocity in the seal cavity to avoid dead areas. So you don't want your mechanical seal to act as a trap for bacteria. It's important that the velocity of the pump and the impellers creating liquid around that area to stop the dead spots. And again, making your mech seal a bacteria trap.
Declan, can I ask a really probably stupid question, because I don't know a huge amount about.
Yeah, no, there's no such thing as a stupid question.
Oh, there is.
Only stupid answers.
So we're talking hygienic pumps, and I can see what you're saying.
Yes.
Are you therefore saying that industrial pumps don't have these, don't have the facility to avoid bacteria traps, etc.? Can you just explain to me in very basic way the difference between an industrial pump and a hygienic pump?
Yeah, that's correct in what you've said. So industrial pumps, they won't have the cleanability, so they can't necessarily do the CIP, which is the clean in place.
And why don't they have that cleanability?
They've just not been. It's just the way they've been designed. So they're not designed specifically for the food and beverage industry. So they may be capable of doing the performance and the pump, and they can reach the flow rates you required. They can reach the pressures. So in theory, if it wasn't for a food application or a beverage application, you can use that pump all day long. that there's no problem with that. But it's when you come into a hygienic environment and it has to be reach a certain level, and the CIP and the cleanability and the compliance, that's where they'll let you down. And that's where there's bug traps and things like that, which obviously you don't want to get into the pumped medium.
Right, thanks, Declan.
No problem. So it's not that they can't do the job as it were, they're just not suitable for the food and beverage industry where you need the hygienic compliance. Again, the parts matter. So the parts of the components of the pump. So you can see an example here of where there's been an application applied to the impeller. You can see in the eye of the impeller there. And this on the right hand side, this is it under the microscope with some mechanical seals. So the top picture on the surface, it all looks clean, it all looks okay. But under microscope, you can see the sort of where the bacteria, the blue is the bacteria. This is where there's bacteria build up in your mechanical seal, which obviously you don't want to go into the food or beverage product that you're pumping. So it's very important that the parts are to the correct standards. You see again on this right hand side under the ultraviolet light. And the same in here. So if you look at the bottom picture, there's bolts and washers. Again, shiny doesn't mean clean. It's all stainless steel. It all looks nice, but you can see these are huge bacteria traps where bugs and nasties can live behind. Around the lip, behind the bolts, behind the washers. Obviously, these are things you don't want to enter into your product.
Declan, I've got a question.
Oh yes, fire away.
Right, just bear with me a minute. I'm just going to do it. So from Felix, you mentioned that you can run the pump all day long. Would you then say that a hygienic pump has less lifespan, or does that simply come down to having to stop to clean it? Obviously, barring any other factors like impellers breaking, etc.
Sorry, could you repeat that question, please?
Yeah.
Sorry.
So Declan, you mentioned that you can run the pump all day long.
Yes.
So from that statement, Felix is asking that therefore, if you run the pump all day long, does a hygienic pump have a lower lifespan? Or does it just come down to having to stop to clean it? Because the pump is running all day long, does it have a lower lifespan than an industrial pump?
No, it depends on the application, obviously, but no, there's no reason that would affect it. Obviously, you have to stop it to clean it, as Felix mentioned, but you'd have to stop an industrial pump if you were using that to clean it. So no, it doesn't affect it. And in anything, the less stopping and starting you do of the pump is actually better, because you're not stopping and starting and using the energy. So it's cheaper for your energy consumption to have the pump running on its best efficiency point for as long as possible, rather than stop, start.
Great. And I've got a follow-up question. Are there concessions made for pump efficiency due to having to design with cleanability in mind?
No, there's not. So it's actually more efficient we use efficient motors, and it's part of the design with the cleanability. So it's the flow path of the pump is designed so that way it's more efficient, so it's more energy efficient, so it saves you money in energy consumption.
Lovely. Thanks, Declan.
No problem. So coming back to the compliance, these are sort of the main hygienic compliance that sites work to. There's the FDA, which is the Food and Drug Administration, the EC 1935/2004. This is this little logo that I'm sure people have seen. It's sort of the fork and the glass. It's the E-Hedge and the 3A. The 3A is sort of it started off in America, but it's becoming more prevalent in the UK and Europe as well.
Declan, does it also, because the pumps are movable parts, does it come under CE marking, now CA marking?
Yes, it's the pumps are CE marking. Yeah, that's correct.
And so your pumps are now, or hygienic pumps, are now fully covered by the new UK equivalent CE marking?
That's correct, yeah.
Thanks, Declan.
No problem. It's also important when pumping is the product integrity. It's a high speed, high efficiency, low cost of energy, which sort of goes back to Felix's question a little bit. And then there's low shear, low efficiency, high energy consumption. So the higher you can see the sort of the tomatoes, see this is a bit of an illustration that they're still whole. At the lower speed, they sort of turn to mush. In the middle, a little bit of both. So it's important what speed the pump run at, what impellers selected, and if it's a low shear or a high shear application, and that varies, that depends on what the pumped medium is, and obviously different applications, different product type. But it's important that it's correct for the application, so you've selected the correct pump for the correct application. So food needs something for food. So some pumps are designed with air handling capability, capable of pumping solids. So if solids need to be pumped, there's the correct pumps selected. There's a big enough entry point and exit point, so you're suctioning discharges and you eye of the impeller that the solids can fit through that. Viscosity, I mentioned viscosity before. The more viscous the liquid, the centrifugal pumps might not be the correct one, but an example is a rotary load pump for more viscous and sticky products. And also the chemical compatibility of the CIP, what chemicals are used in the CIP, and the materials of construction capable of standing up to that. Again, coming back to CIP, which is important for the hygienic pumps. Can it stand up to the temperature? They can be quite hot, often up to 85 plus degrees. Strong chemicals can be used, so it's important that the elastomers selected can stand up to that. The repeated cycle, so repeatability, is it every day, every 12 hours? And corrosion and fatigue, is the pump capable of standing up to the chemicals and the repeated cycles, where some industrial pumps aren't designed for the temperature and the strong chemicals, such as caustic soda, which is often used in CIP. Sometimes the industrial pumps, the elastomers aren't appropriate for that. But again, it depends what's been specified. This is an example of a hot side and a cold side of a brewery. That goes into further details on the next slide. So an example of some applications on the hot side is cold and hot water, 80 to 85 degrees centigrade. Mash, up to 78 degrees centigrade. Wort and trub, up to boiling point. Hops and hop dosing. And again, CIP processes where applicable. An example of some on the cold side. Wort handling, cooling, yeast handling, beer transfer through the filtration, kegging, so getting the beer into the kegs or the bottle lines or canning, washing, and again, clean in place. And there is applications in breweries where you can use industrial pumps. You don't have to, they're not all hygienic. There's applications where, but again, it comes down to what's specified at the time of selecting the pumps. Hygiene, a choice to make. The three important parts is the compliance. Is it meeting the standards that's required, set by the trading standards for the food and beverage industry? engineering, maximising the output of the product, and the commercial operating costs and the reputation. So if, for example, if bugs get into anything from a commercial point of view, it's bad for that particular business. So it's important that the pumps are hygienic for them, for the correct applications, to avoid anything like that. And sort of this is the end slide. So this is some pictures of our hygienic facility, which is based in Belgium. So this is just an example, and obviously this is Verder. We manufacture and distribute specialist hygienic ranges. So that reaches the end of this short presentation. So any questions that anybody has?
I'll pop in with one. Have you got any examples or case studies, Declan, of where the wrong decision of a pump impacts the costs of production? It might not necessarily be between industrial and hygienic, but just the wrong pump for the wrong job.
I can't give you specific examples of customers, but an example of that is obviously the cost of downtimes to businesses. So production lines, if a production line is down because the wrong pump's been selected, that can cost the business thousands of pounds an hour in downtime and maintenance. So that's a big, obviously the cost of selecting the wrong pump at the beginning, whether that become a factor, you can then in the long run cost you a lot of money if the correct pump isn't selected in downtime and maintenance for the production.
Thank you. And do you work to company standards or trading standards?
And both. So as an example, back to the compliance slide, our pumps can be specified to 3A, FDA, things like that. So all the standards that are EHEG that are required, our pumps can be specified to that standard. And obviously we have our own ISO standards internally.
Great, thanks, Declan. I can't see any more questions. If anybody wants to ask a question, please just bash it into we've got one. What do you need to look out for when selecting a contractor to service a hygienic pump?
Sorry, could you just repeat that question, Ruth?
Yeah, so
you need to look out for when selecting a contractor. Is that correct?
If you're looking for a contractor to service a hygienic pump, what do they need to look out for to make sure they've got the right contractor? Obviously,
just that they're capable of doing it, but also that it's going to be done in a clean environment. So, for example, if they have their own workshop, if they're using stainless steel pumps, there needs to be a stainless steel specific hygienic area. And for example, you wouldn't want somebody using the same tooling and the same workbenches who've just been servicing a pump from a wastewater treatment plant, without going into too much detail this early in the morning. You'd want it to make sure that it's a specialised hygienic environment where they're taking the pump away to service it.
Is there, I mean, I don't know, is there a listing somewhere of is there an accredited service engineers listing or not?
Not that I'm aware of, but I'm sure I can look into it.
Yeah, I mean, it's just helpful, isn't it? Because you don't know what you don't know.
Yeah, exactly. Yeah, and obviously it's important that they have up-to-date training. You know, the person who you're sending the pumps away to, or if they're servicing on site, the correct experience, qualifications, credentials, things like that.
Brilliant.
As an example, if you had a plumber to service your boiler, you'd want to see the gas safety certificates and things like that. So just look out for things like that, and also that it's going to be, if they are taking it off site, that it's going to be serviced in a clean environment with clean tooling and completely decontaminated, and they've not been using the same tools and the same workbenches for wastewater treatment pumps beforehand.